Welcome back, everyone. In this video, I'll be continuing the section on cylindrical shells. Now, at this point, we've done a lot of examples with cylindrical shells, and we did a lot of examples in the previous section of washers versus discs, how they work. But really, those are grouped together in terms of finding volumes of revolution, and cylindrical shells work slightly differently. They give us the same answer because they're both giving us the volume of something, but the question is, how do you know which one to choose? Well, the real reason I know which one to choose, as I talked about before, is that it really depends on your picture, what you're rotating around. So whether it's horizontal or vertical axis of revolution, and then what the equation of your curves are. So this is usually my general rule of thumb here. It says if your region is bounded by the curves of the form something with x, so y equals f of x, y equals g of x. I'll scroll up and just refer to this problem right here, number 2. We have two equations that are given us as y equals stuff with x. And the thing is, what you want to do is, if your curves are given by this, regardless of what your axis of revolution is, then vertical cylinders or circles will almost always work better. So what I mean by that is, I'm not trying to pay attention to this, just this little section here. If we're doing vertical things, then the height of this cylinder is very easy to write because it's a vertical slab. Now, one thing is that, if our axis of revolution is also vertical, since they're parallel, this is the reason why we would choose shells over the washer disc method. But you could imagine if the thing we were rotating around was actually the x-axis, then our shells, which would be horizontal because they have to be parallel, are no longer being represented. They actually look more like this disc and washer method, and they have the same problem here. So we would still want a vertical slab, but this time, because we would be rotating around the x-axis, we would use the washer method. Right? And maybe you just need to pause the video, kind of think about that for a second. But what we're really saying here is that if we have y equals x, y equals functions in terms of x, we want to draw a vertical thing. And then just remember, cylindrical shells, our little slab that we draw needs to be parallel to the line of revolution. And then if we use the disc or washer method, it needs to be perpendicular. So with a vertical slab here, if we have a vertical line of revolution, we use shells. If we have a horizontal line of revolution, we would use the disc or a washer method. And it's similar for the opposite situation. So if you have, if your region is bounded by the curves of the form x equals, now keep in mind that when I say x equals these two things, you might only have one equation. We've seen that sort of like in this problem here, where we only had one equation where it wasn't a horizontal or vertical line equation in the last example. But if your region is bounded by curves of the form x equals, then you want to draw horizontal shapes because it's easier to represent the height if you're talking about the cylinders, or the radius if you're talking about the circles. So that's something to keep in mind. But if you still use the parallel thing for shells, the perpendicular thing for the washer or disc method, then it should help a lot. So all we're going to do in these three problems is look at the region that we're bounded by. We're going to look at the line we're rotated about, and we're just going to say, should we use cylinders or should we use the washer or disc method? That's all we want to do in this section. And with that, you really just go through these two things. So let's go ahead. The first thing, before I even draw anything, you want to notice is that we have, for this first one, the volume of the region bounded by y equals x squared, y equals x minus x squared, and y equals 0, rotated about the line x equals 2. Now, if you're very comfortable with graphing all this stuff, you can sort of go through it in your head. But what we'll point out here is that this is the first situation above. We have y equals a function of x. So we want a vertical, and we're either going to choose cylinders or circles, meaning disc or washers, depending on which one it would be. But we don't know which one the main thing is that we want vertical so far. So as soon as I see the y equals, I want to use vertical. Now, unless you're told in a problem you have to use cylindrical shells or you have to use washers or you have to use disc, it's totally up to you. And this is how I go through it. So I see this, I know I want to make vertical shapes. And then if it helps, you can also graph some of this stuff. So I'll graph it after, but when we see this, this is a vertical line. X equals is a vertical line. Well, if we want vertical cross sections, the vertical little slabs that we draw, and we want to rotate it about a vertical line, that means vertical and vertical are parallel. Okay, so let's just kind of narrow this down completely. We knew we wanted to use vertical based on the y equals parts here. We had a vertical axis of revolution, x equals 2. And at this point, we just pretty much draw look. Are these both vertical, both horizontal? That would mean that they're parallel, and we would use shells. And that's exactly the situation we have here. Since they're both vertical, we want to use shells. And we can go ahead and just graph this so you can see it. But just based on these two things, I knew I want to use shells. It's still really helpful to graph it anyway, because it might be hard to see what is your radius, what is your height. So you still want to graph it, but the point is we can figure out which one to do. So we have y equals x minus x squared minus x squared. Y equals 0, which is the x-axis, so you don't really need to draw that in. And then we're rotating around x equals 2. Scroll out here because it's the vertical line over there. And you can see it's exactly what we would want vertical, or we would want cylindrical shells for. If we set up the shells to have heights over here, then we could say the height is the top one, which is x minus x squared, minus the bottom one, which is 0. So we can easily get the height of the cylinder. And we can also get the radius because it would be 2 minus x. We're running through the x values of 0 to 1 here, but it would just be 2 minus x. Now you can imagine rotating this, and then if you try to use the washer or disc method, and it would be the washer method here, well, our slabs would have to be perpendicular, so they'd have to be horizontal. Well, what's wrong with that is the left and the right horizontal parts are the same equation. And we talked about the situation, which was the whole point at the beginning of the cylindrical shell section, is that you would have to solve and get two equations, x equals here, to represent the left and the right, and that's very hard. So we do not want to do that. Now, I didn't want to do anything else in this section, just, really kind of talk about it. But if you want to go through and set it up, that's what I just talked about. Then the volume here, which I'm not going to solve for, but we have the bounds on x because we're looking at vertical slabs from 0 to 1. The height is the green minus the purple, so x minus x squared, then minus 0. And the radius is 2 minus x. So putting that all together, if you wanted to set up the solve, we would have the volume 2 pi from 0 to 1. The radius was 2 minus x, and the height was x minus x squared. Now, the most important thing about these problems that I have here is just to notice which one to do. But it does help if you want to go through and just set it up to know that it's actually doable. All right, number 2 here says the volume bounded by the region x equals 7 y squared. Y has to be greater than or equal to 0. We also want to be bounded by x equals 7. And we want to rotate about the line y equals 2. Right, but let's go ahead and go through the same steps that we did here. We care about the region, how it's bounded in its equation, and then the type of line that we're rotating around. All right, so let's go ahead. What are we looking at here? Well, this y is greater than or equal to 0 is really just the region bound. So if we graph this, it must be the fact that If we didn't say this, then it would be a slightly different region than what they actually want us to rotate. So it's not going to have a big impact. But the real one I'm looking at here is the x equals 7y squared. Even the x equals 7, that's just a vertical line, so that's less important. This is telling me I really want horizontal because I have x equals. X equals functions telling me I want some horizontal things. So I'll just write horizontal now to save us some time. But what we're saying is we don't know which one we want to do yet, but we want horizontal cylinders or circles. And the other thing we want to highlight is what we're rotating about. We're rotating about y equals 2. Well, y equals a number is a horizontal line. And you can see this is another problem where the setup is the same. We have horizontal and horizontal. That means they're parallel, so we should use cylindrical shells. Once again, I want to really reiterate that you should always graph these. I'm just going through and showing you that you can figure all this stuff out without graphing it. But you really don't want to try to figure out, once again, the radius, the height, whichever method you're using. So let's go ahead and just do that. We have x equals 0. I don't know why I graphed that one first. It's because that's not even x equals 0. So it's x equals 7y raised to the 2. And then we have x equals 7. Now, if I go ahead and scroll out here, you can see why we have the y is greater than or equal to 0. And that's because it only wants us to rotate the top half here. So this little section, we only want to rotate the top half. I'm not sure if this will work well. Y is greater than 0. Okay, and maybe you can even add in the equal part here. No, yeah, if you press the equal sign, then it'll actually make that line solid for you. But the point is, it wants the shaded region inside these two. So it wants us to rotate this about y equals 2, which is right here. Go ahead and graph y equals 2. So I want to rotate this about this line. You can see that if I set it up, if I do horizontal here, which is good because the height of the cylinder would be this minus this, 7 minus the 7y squared. I can set up everything, and the radius would be a 2 minus y. And the bounds here would run from y equals 0 to y equals 1. But you can see that the shells here would be a good choice. Now, is it better than doing the washer method? So if we add vertical slabs, maybe, maybe not. But because I have x equals already for my equation, it should be easier to use cylindrical shells. So we can go ahead and set it up like I just talked about. We got the volume here. We got 2 pi, 0 to 1. That was the y bounds. What was the radius? The radius here, so this is our slab. The radius is the top 2 minus the bottom, which is y. So we're just running through the y values from 0 to 1. And then the height is the 7 minus 7y squared, because it's the bigger x value minus the smaller. So we got 2 minus y times 7 minus 7y squared. And once again, you can sort of set this up, but the point here is that if you can easily write the radius and height and just plug them in, then you should be able to integrate this. The point of this little section is just setting stuff up. All right, and then the last one we've got here, we've got the volume of the region bounded by y equals negative x squared plus 7x minus 6 and y equals 0. So directly, this one I see y equals, once again, the y equals 0 is less important. It's really the ones with all the x's here. So that's telling me I'm hoping to use, and I should plan to use something that's vertical. Right, y equals 0, or sorry, y equals something with x means vertical in my head. So I want to do that. And I want to rotate around the x-axis. Is the x-axis vertical or horizontal? And it is horizontal. Now, vertical line and a horizontal line are perpendicular, which means we want to use the washer or disc method based on our picture. And we can go ahead and just kind of remember that For the washer or disk method, we use just pi because it's pi r squared. We make circles. If we go ahead and graph these things, I'll go ahead and just graph it down here and then I'll move it up. We got y equals negative x squared plus 7x minus 6 and y equals 0, which is the x-axis, rotated about the x-axis. If we go ahead and just look, it's telling us to take this little region that it's bounded by and rotate about the x-axis. So this is the disk method. You can see why we'd want to use the disk or washer method though, is it's easy to write the radius of our circles here, because if we run through these x values, if we have vertical slabs, we're going to make our circles and the radius is just going to be this curve equation, top minus bottom. So it's the negative x squared plus 7x minus 6 minus 0. And it runs from the x values. You can see here it's from x equals 1 to x equals 6. So we got pi, the bounds from 1 to 6 of r squared, since it's just the disk method. And we had the radius was negative x squared plus 7x minus 6 minus 0. So the top minus the bottom one from our picture squared dx. So that's all we have to do because we're only setting this one up. But once again, the radius here, since we would be rotating it about this line, the x-axis, y equals 0, it all hits the bound of our region. So that's going to tell us the disk method. And from there, the radius of the circle would be exactly this equation minus 0. So top minus bottom. And we will run through the x values from 1 to 6. And that's all you have to do here. But the point here is that if you can really set it up based on just the equation, I almost think that's better to figure out whether you're going to do the washer or disk method by doing this and then graphing it. So the problem I have is if I graph it first, then I kind of want to look at the picture too much. And the picture should only be used to figure out the radius and the height after you decide which method to use. Right? But that's it for this section, and I'll see you in the next one.